Hi, in today's class, we want to talk about functions. Not the functions that I've given you or that are available in one of the C libraries, but functions that you could write by yourself. We're going to show you how you do that in this lesson. Okay, so here we have a piece of code where we've already using some functions. For instance, this configure UR2 is a function I've written and given to you for communicating when you're using the PIC. We're in the simulator right now, so it's not quite as important. We've seen this printf statement is a function that's in the standard input-output library and lets us do a lot of useful things. So we're quite happy with that. Okay. And here we've seen some for loops. Okay. Now, this is a very short program, and it's easy for us to put it all in one main. But you know, large commercial pieces of software like Windows or the Mac OS or Word, right? All of those programs are millions of lines long, and you don't just sit down and write them. The easiest way to start code is to write small groups of what are called functions. Like main here is the function. It was the first function we introduced. So if you write your code in terms of small functions, then it becomes easier to build up programs as bunches and bunches of little functions. This is how professionals write code. Okay? It's okay for you to write 20 or 30 lines in main, but if you want to reuse that code, writing functions is a lot easier way to go. Okay, so I want to write a function. Okay, so how do we write a function? Well, if you're in the main, then typically under your main, you can write a new function. Okay? And the general structure of a function is data type, function name, list of variables, if any, data type, that's data type, sorry about that, and code in here. Okay. Now we've talked about data types. Data types are things like this right here, unsigned int. That's a data type. It's telling you how much memory to store to hold this in memory. Okay. The sort of data types that we're used to are integer and float. Remember, integer can be signed and unsigned. And as well, there's also a data type that we haven't mentioned too much, which is void, no data type. Now, the purpose of a data type in a function name is that you return one number, if any, right here. So in here, this, I'll put it in curly braces just for a second, right? Okay, is a number. So if I go up to the main, for instance, it's defined as int, right? And down here it returns a 0. Right? So 0 is an integer, and once this is done, it returns a 0. We're never looking at that return 0, but in other functions, we definitely do. The variable list for our main is void. There aren't any variables in here that we need to use. Okay? So let's start by building the simplest function. That's one that's void. It's not going to return any numbers. Okay? And because it's not returning any numbers, I could just say return, or I could even just leave out the word return. Okay, so what kind of void function would I do? Well, what I'm going to do is this message here, I kind of like. Maybe I'd like to reuse it in a different program. Rather than searching for it in here, I'm going to have it in this function. So let's get rid of this. Okay, so here it is. Okay, so now I have almost a function, right? In here, I'm not using any numbers, so my list of variables, that can be void. I just have to give it a name. What would I call this? How about P1600 message, right? That would be a good name. That sort of sums up what this is doing. Okay, so now I have a new function. And I can call this function from my program. So up here, to call it, all I do is I use the name of the function, P1600 message, and I don't put anything here in front of it because it's not returning anything. And here, it's not taking any numbers, so I can just leave it as empty. It does need a semicolon at the end, like any other line of code. Now, that's perfect. This is a perfectly good function, right, as I've made here. And I am calling it. But there's one more condition when you write functions. When this reads this code, right, this compiler's going to come to this and say, that's a function. I wonder where that's defined. And it is defined down here, but up here, we have to explicitly tell the compiler that we've created this function. So I just copy this right here, put this up here, okay, and put a semicolon at the end. This is known as a prototype. The first time through, when the compiler works through main and sees this, it reads this and says, oh, there's some code somewhere, so I don't have to worry about this, right? It is defined somewhere. It's up to me to make sure that I have, in fact, defined it somewhere. Let's see if this works. Let's see if I've done this correctly. Okay, let's go to the output. And there it is. There's that message string, right? And as well, the second printf statement down here has worked. Great. We've created our first function. Okay. It's not all that impressive, and it's not totally useful, but it is reusable. I could use it later in other functions, other programs that I write. Okay, we want to do something a little more exciting. Basically, any chunk of sort of self-contained code that you see in your main function can be turned into another function. Like all of this can be turned into another function. Okay, so why don't I do that? So I'm going to come down here, right? Start another function. Okay, so because they're easy, I'm going to start off with void. And I'm going to need a name. So we're summing a series. So why don't I call it sum series? And I'm not going to use a variable list just now. Right? But what I'm going to do is I'm going to cut and paste this. down to here. And I'm going to prototype this here. So bring this up to the top. The semicolon, and there's my prototype. Okay. Now, this is doing something a little different, right, than the other one. I'm getting little question marks here. It says, I'm unable to identify what I is. Okay, so this I is a variable, but it's a variable that belongs to this function here. Up here, I made room for I when I had that code. This needs to be with that code down here. And so at the start of this, I have to have room in my function for every variable in my function. Okay. So are there any other variables here? Yeah, sure. There's the sum variable. So let me come up here and cut this out and put it in here as well. Okay. So now you can see all the little warnings have gone away. I've got a perfectly good function that does this summation for me. Right? So I want to call it, and again, it's the similar sort of calling, sum series open close brackets. Right? There are no variables to go to. Clean things up a little here. Okay. So again, if I've done this right, these two bits of lines will be replaced by this when it gets compiled and runs. And let's build. Go to the, and you can see that, yeah, sure, it's plotted it out again, exactly like we had before. Okay? Fine. So taking a chunk of code and turning it into a void function is dead easy, right? You just plop it in, right, and call it like this. It's done. But that's kind of limited, right? This sum series doesn't do too much, right? So if I look at this, so you know, I'd like to generalize this function a bit, right? What if I didn't want to start at 3? Maybe I want to start at 0. Maybe I don't want to go to 100. Maybe I want to change by what number I increment. It turns out that's easy for me to do. All I need to do is come here and say, I want a new start value. Right? Start, right? I'd want a new end, and I might want a different increment, right? And so down here, start, end, and plus equals increment. Okay? So if this program changes, so up here I'd have to change this, say I want it to start at 0, go to 100, and increment by 2's, when this program gets called, start will be 0, increment will be 100, end will be 100, and increment will be 2. Right? You can even see in the program right here that it was trying to tell me where it's been called. And this should work quite nicely. Start, end, and increment are variables just like I here. And just like I, we should specify how much room they need. So we're using integers here, so we will make them all integers. And whatever we do down here, we have to do to the prototype up at the top. Excuse me. Oops. Did I get that right? Yes, I got that right. Okay, so that's right. And I don't need to do it over again down here because this is the same in the list of names as doing it here. So that's perfect. So I can do this any set of numbers I want. Let's check to make sure that that works. Here it's printing out. No answer. Perfect. So it does seem to work. So we've made some series more general by letting us vary the start, the end, and the increment. But it's always printing out the same message. And maybe I don't want the sum. Maybe I need the sum, but maybe that's in part of a calculation where I then want to double it. So typically in our functions, we don't do the printing in the functions. It's when we get the number back that we decide the message we're going to print out. So I'd actually like to take this function, and when we get the answer back, print out, say, double the sum equals 2 times that. Okay, but how am I going to do that, right? Because down here, nothing's coming back. This is void. Well, there's two ways of doing that. One way is to use something called a global variable. Okay? So I'm going to copy this term right here, and I'm going to come up here, and instead of putting this in one of my functions, I've defined it outside the function. So that makes this a global variable. Any function can access it or use it. So now, if I run this program, sum will be changed down in this program, and this program will know about it. Okay, let's go to the output, stop, and hold on, the sum is not 2550. There's a simple reason for that. When I made this global variable, and I said everybody can access it, everybody can, but they don't necessarily need to access it. Down here in this function right here, I've got the same variable defined, unsigned int sum equals 0. If you use the same variable name again, it takes precedence over the global variable. The locals take precedence over the globals. So here I said it was 0. So the compiler doesn't think this sum is the same as the global sum. So I need to get rid of that. Just like that. And now let's see what happens when I compile. Okay, let's go to simulator, UR2, and now we're back to something that we should expect, right? Double the sum. is 5100, right? I don't know why it's double the sum. Might be because of the values I've created here. So we've got double the sum is 5100. If I go back up here, I see that sum was originally 2550. So yeah, this seems to be working nicely. Okay, so we certainly can use a global to pass information back and forth between a function. But if two functions are using that same global variable, things can start getting strange really quickly if they both are changing the value of that variable sum. A different and preferred way of getting information from a function like this is to use the return. It would be simply that we return sum. Right? So where I had it as a global variable up here, get this out, and back down here. This is a local variable again, but now I want to return a sum. Sum's an unsigned integer, so instead of this being a void function, it's an unsigned int function, and we only need to go back up here and get the values. Okay? And the way we do that is unsigned int sum, and I let sum equal this guy. So now when this calculates a number, it passes it to the variable sum, which I can double. Let's see if that all works properly. I'm going to delete this. Okay, error 1. I got some typos. Never good to have typos. Let's try it again. More typos, no doubt. Unsigned in some series. Oh, right. Up here, I forgot to make that an unsigned int. Okay. The prototype always has to match the function. Build successful, simulator's opening, and we go to UR2, and it works. Perfect. So, to sum up, virtually any code that you would write and put inside a main can be turned into a function. Functions are a good way of keeping your code reusable and more understandable. It's easier to write a function and test it than in a complete program. Programs return nothing or a variable like an unsigned int or a float. They can take no information from you or as much information as you want. A variable list, in other words. The function should always return a variable of the type that you created it to be. Functions are always prototyped at the top of the file. That's it for now. We're going to show you in the next little video something that you can do with your functions, turning them into a library.